So thank you very much for the opportunity to speak today. We're going to speak a little bit about making post-combustion capture happen. I think this HAS Cloud project is a perfect example that it can happen, and wanted to share the Linde perspective with you on that. So would you take that out? So just to make sure, carbon capture is a big area. What shall I focus on today? CO2 from power generation, because that's of interest to us here. Post-combustion capture, as mentioned, and the CO2 is to be used for enhanced oil recovery. That doesn't mean that other technologies don't work. That's the perspective for today. We are very convinced and positive that projects can happen today, but as you see on the right-hand side, you really need to go through those 3 steps, which is you need a certain technology maturity, you need a scale-up capability, and you need commercial synergies. And I'll just give you a brief overview of each one of those. The end of the story really is you need a large number of success factors, but they can exist and they can come together. Just very briefly, I had the opportunity to introduce Linde earlier, so I won't spend much time on this. Just to show you from what perspective we're coming. We're an integrated technology, engineering, and industrial gases company, one of the largest and represented worldwide. We do EPC for our own technologies mostly, and the gases company actually owns and operates many, if not all of those technologies, so we bring the experience back into the engineering side. Carbon capture is an integral part of that, and just the best way to remember Linde is not by all these facts and figures, but Carl von Linde in 1879 finally figured out how you can get a cold beer in summer by inventing the refrigeration cycle. So that's probably the most appropriate way to remember us by. So technology maturity. What we do in-house is we look at all the technologies we can find out there. We map them on a technology map from basically the basic research cycle or phase out there, moving progressively to pilot, to demo, and to commercial. And as you can see, there's a huge range of technologies trying to make carbon capture work. And that's great, that's really wonderful. You can see on the outside, you've got a lot of universities. As you start moving in, you've got a lot of startup companies. And then as you start getting to the inner circles, you've got the big players. And if you want to do carbon capture not in a demonstration, but in a commercially practical way today, you really need to start to be in those circles to get folks to put down hundreds of millions of dollars to build these projects. It is really tough to build a $500 million project or a $1 billion project if the technology is out here. You just won't get folks to invest the money. If we look at scale-up, the second item I had, I always get confronted with people saying, how do you want to scale up from a 1 megawatt pilot to a 250 megawatt demonstration plant? That's what it looks like on the face of it, but really it is, what are you scaling up? You really need to ask yourself, what are you scaling up? So just to give you the Linde perspective, and I must make one correction. For this technology, BASF is our partner. There should be a little logo up here. It's not. If we distribute the presentations, their logo will be up there. But if we look at the scale-up for this partnership, Linde BASF, for the post-combustion capture system, if we look at the chemistry of carbon capture and solvents exists for a long time. BASF had it for a long, long time. It just needs to be adapted to capturing carbon from flue gases from power stations. To do this, we've built with BASF in Germany the first pilot plant that demonstrates that. It demonstrates capture efficiency, it demonstrates solvent degradation, and it demonstrates emission conformance. We are busy with a second facility here at the Southern Company, Wilsonville, site with a second pilot to test newer ideas on the same thing. Materials is the second element. You want cheaper materials of construction, so you test those in these facilities. This facility is running since 2009, so it's done. We know the chemistry works, we know the materials work. When we come to the size of the facility, it really is about column diameter, not column height. Okay, column height gives you purity, column diameter allows you the throughput. And both Linde and BASF today are already building 12-meter diameter columns, which is really the kind of diameter you need for a 250 megawatt capture from coal facility. So when you look at this picture and look at what's the real scale-up risk, it's the integration of those elements. We can build at the size, we don't need to prove that, we've proven that. It's adapting existing chemistry, not reinventing it, and it is proving out materials of construction. To finish off this slide, as Linde, we've taken a linear alpha olefins facility, a pilot, from 8 kilograms an hour in one step to 150,000 tons a year in 2005-2006 in Saudi Arabia, which is a 2,350 times scale-up. But once you look at this picture, you will understand that a number like this is misleading. Okay? So that's scale up. So let's get into the commercial aspects of PCC quickly before we close it out. A busy slide. Let me just show you a couple of elements. We've done rough indicative economics. Please note rough indicative. And to the students out there in the audience, just because the line is thin doesn't make it more accurate. This is just to show that there's a solution space. You can take a dig back at me later if you like. So, if we assume you recover from EOR 2 barrels of oil per ton of CO2, which is a conventional number that is often used, and you assume a $100 oil price, you can afford a CO2 price in this $50 to $100 range really. If you now look at what your power needs to cost, because these systems consume a hell of a lot of power, if you use an existing coal facility, you need to be really at 4 cents or below, because you've got an existing revenue for the power that you are stealing from in order to drive this carbon capture facility. If you build a new gas plant, you are generating new revenue by building the facility, and you need the power to help, the power sales to help fund the project. You need to be, let's say, at 8 cents plus. This doesn't work everywhere in the country, but it does show us that there is a solution space. That's all we're trying to demonstrate. Now I'm going to jump the left-hand side here. I want to save time, but let's talk about the right-hand side quickly. Getting projects together is not so much about making the spreadsheet work and to show that there's a profit at the end. You've got suspicions of the new. You've got new partners coming together. You've got power companies, industrial gas companies, engineering companies, financiers, and oil companies. So the oil company, the first thing they tell us, we know the oil will come when you give us the CO2. But if you build one of these magic facilities, how do we know the CO2 will come? Okay, big question. From our perspective, it's don't worry, CO2 will come. That is absolutely no issue. But when we pump it under the ground, we really don't understand it. How the hell do we know the oil will come out? And it is really, I'd like you to ponder this point. This is one of the biggest issues of bringing these projects together. And that's where you need to find the right partners who are prepared to go out there a little bit into the new realm, outside their industry, to understand how these projects can work. And then government is a key ingredient to making the first projects work. That is not to be underestimated. That is not just from a funding perspective, but it is the MVR implementation, that you can actually properly record the CO2 stored. And then, of course, it is about grants, tax incentives, and other incentives to make that work. 2 slides, and then I'm done. We're quite excited about the USA as a place to make this work, okay? Because I believe, or we believe, there are a lot of ingredients here that are in favor of these projects. Europe was originally driving the carbon capture agenda, and that has really lost significant steam over time. And as you can see here, there's quite a lot going on in the US. Why? First of all, power production. You know there's enough of it in the US. It is geographically dispersed, and if you need carbon emissions, you will find them almost everywhere where you will go. That sounds obvious to you. You go to Saudi Arabia, do ER with CO2, you cannot find the emissions. So that's what I'm comparing it to. Oil production. The US has very accessible, widely dispersed, onshore, mature oil that has been proven to work with CO2. In one sentence, there are a couple of success factors in there that really help move this along. If you go to many other countries in the world, it's offshore, they don't know how to work with CO2, it's national oil companies that are scared to do projects. We've got an oil industry here that is very, very much in favor of taking that CO2 and producing more oil. Then we've got the role of government. There's an increasing focus to limit CO2 emissions, whether you like it or not. I'm not here to comment on that, but that focus is increasing. There's a very lively debate more at state level on the MVR measurements, and there's a really strong support from the DOE on technology and first project development. And we will complain about insufficient government funding, but when I compare it to what's going on in Europe, you really can get stuff done here. And a lot has moved forward on that basis. The public. Once again, you will have different opinions on it, but you can actually build projects here. The one thing the Europeans figured out during their demo project phase, which is a grand failure, I would say, is that they don't want pipelines running through their backyards, and that they do not want to store CO2 underneath their villages and houses and cities and towns in natural gas reservoirs that have been there for millions of years. Projects that we run pipelines, that we pump CO2 into the ground, that we permit new chemical facilities, is absolutely part of the deal when you work in the USA. Sometimes it's difficult, sometimes easier, but it can be done. So, last slide, summarizing. Capture technology is available today that can be built at scale. Okay? So that's the first ingredient. Without that, you don't even need to start, but you need providers that have deep capability and that can really back, in a project financing environment, that can back the performance and the completion of this technology. The economics aren't fully self-evident yet, but at greater $80 per barrel oil price, there is a solution space where it can work. The partners that you compile really need to have a shared vision. They cannot just be passive partners. They need to want to make this work. And that is really, really, really critical. Government, as I said, is a key role player in this. And I think here in the US, we are actually quite well endowed on that front. And I want to close really by summarizing, I think we're in one of the geographies where this can really work. I thank you for the opportunity. I think from the projects that we're hearing, we're showing that it is working. And I encourage all of us to continue working along that line. Thank you very much.